Hello everyone, my name is Arushi Garg and I'm the Circle Manager of EIMS Circle from GDSC IGDTUW, and today is our final session. So today we'll be building a model, or we can say a mini project. In the last few sessions we talked about various concepts including introduction to machine learning and artificial intelligence. Along with that, we discussed exploratory data analysis and data visualization. Then we move to various algorithms, and we majorly classified into three types: supervised, unsupervised, and reinforcement learning algorithms. And then finally, we talked about various algorithms, including linear regression, logistic regression, and KNN, that is K nearest neighbors. So today we'll be building a model, a project, so that you will understand how to apply these concepts to real life problems, and it will give you a much better clarity of all these algorithms, and you will finally understand how you have to build a model, a project, and submit it to various hackathons and challenges, including Google Solution Challenge. So let's start with it. Okay, so this is our data set. What we are actually doing, we are predicting heart failure. We have various parameters, including age, anemia. 0 tells that the patient does not have anemia, and 1 tells that the patient does have anemia. Then creatinine, phosphate, diabetes, again 0 and 1. 0 means no diabetes, 1 means yes diabetes. Then ejection fraction, high blood pressure, again 0 and 1. Platelets, serum creatinine, serum sodium, sex, smoking time, and finally the death event. So from the given data set, we can say that there are total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30. Oh, yeah, 13 rows, sorry, 13 columns, out of which 12 are the parameters that will be used to tell whether the death event will be 1 and 0. And in total, this data set contains about 300 rows, as in 299 cases. So these are the parameters: age, anemia, till smoking time, which will predict the death event. So we can say that this is a prediction model that we'll be uh, generating today to predict the death event, or whether the heart failure has taken place or not. So without wasting any time, we'll be moving to the Google Collaboratory. So in previous sessions, we have already used Google Collaboratory, and you are quite familiar to its IDE, and you guys already know that how it works and how do we code in it and what are the shortcuts and etc. So we'll be directly starting with the project, but first let's revise and let's see how Google Drives are mounted. So here we need to wait till we are connected to the runtime, and yeah, we are connected to the runtime. Then clicking on Mount Drive, connect to Google Drive. Yeah, so our drive has been mounted. We can see here drive, my drive, and now here we can see all the files and folders we have in our drive. So we need to search for the required data set. So yeah, heart failure, clinical records. So before importing the data set, let's import the required libraries. So NumPy, Pandas, Matplotlib, and Seaborn are the fundamental libraries that we'll be needing. And apart from that, we'll be needing sklearn for implementing our algorithms such as logistic regression, k-neighbors classifier, and etc. It is also required for splitting the dataset into training and testing, so on. So let's import the libraries. Our libraries are finally imported. Here, if we click on the file or the dataset, we'll get three dots and we need to copy path. And here all we need is to paste the path. Our dataset has been successfully imported, so we can cross it. And to check whether our dataset has been imported or not, we can click on df.head because df is an alias name given to the dataset. We'll be referring our dataset with the name df. If we type df.head, so it will show the first 5 rows of our data set by default. If we write here 10, sorry, if we write here 10, it will show the first 10 rows of our data set. If we write here 15, it will show 15 rows of the data set. But if we don't write here anything, by default, it will show the first 5 rows of our data set. Then moving on, df.info. So here the information we got is that these are the columns of our data set and non-null count, as in there are no null counts in our data set. Null counts means the value is missing or not present in the data set. But in our data set, all the values, all the rows and columns are completely full. So there are no there are no null values. All the values are non-null. And then next column tells us the D type, that is the data type. So age is float, anemia, creatinine, phospho, I don't know how to pronounce it. Then diabetes, ejection fraction, high blood pressure, platelets, all in int 64. Sorry, high blood pressure it's in 64, platelets and serum creatinine in float 64, and then continuing serum sodium, sex, smoking time, death event all in int 64. So we can say that out of all the data types, three out of all the columns, 3 columns are in float 64, 10 columns are in int 64, and the memory used is 30.5 KB. So this is what we have got the information. Then moving on. So this code has helped us to describe our data set. If we only write df.describe, the result will be this. But in case we want to take the transpose and get our analysis done in a much better way, not better way, um, in a more representative way. So all we need to do is click here transpose. So our DF, that is our data set, has been described here. The count, then the mean of all the values of that particular column, that is 60.833 and so on, gives the mean of the age. Then SAD gives the standard deviation. Then minimum, the minimum value in that particular column, 25%, 50% and 70 percentile, right? And then maximum value of that particular column, right? Then moving on, this is the heat map, and it tells that if any value is null or not. But since we can see that it is completely purple, so we can infer that there are no null values. Null values means zero, not zero values, blank values. So is null means whether it is a null or not. Moving on, we have built this heat map to draw the correlation, to get the correlation between the various parameters and various columns. Here we have tried to find how every column is dependent on every other column. So talking about age, so how age is related to anemia, creatinine, diabetes, ejection fraction, etc. But if we talk about our main concern is death event, so we need to find how death event is correlated to all the parameters so that we can find out the major parameters that affect our death event. Yellow means that it is directly proportional and dependent, like with the one correlation, and dark blue represents -1. That means that uh, the parameters or the columns are inversely related to each other. Moving on. So we can say that those parameters which are correlated to death event with more than 0.1 value are the um, are the parameters which actually contribute in finding the death event. So these are age, ejection fraction, serum creatinine, serum sodium, time, death event, which means that um, columns such as anemia or diabetes or platelets, etc., don't play any role in determining whether the death will happen or not. Then here we have plotted a count plot between the death event and sex. This is what we are doing. This is we are just analyzing our data set, because if we can't analyze, if we don't know much about our data set, if we don't have much insights of our data set, we won't be able to perform the machine learning models. We won't be able to generate the best machine learning models for our data set. Okay, so herein we have what we have done. We have plotted count plots and how how anemia, smoking, high blood pressure, and diabetes, which are not much related, which are not much correlated to the death event, have shown the results. So this was the very basic analysis. Then here we have plotted the box plot, which tells us about the outside outliners. So outliners means that, yeah, they are part of a data set. But okay, let's take this example. Like talking about a class, if we need to find the result, so in an exam, out of 60, majority of the students have scored marks between 20 to 40. But obviously, there are certain intelligent students who always score 55 out of 60 or 60 out of 60. And also, there are certain students who could not score much marks, so they score 5 or 10 out of 60. So, these are the outliners which will definitely hamper the average or the analysis of the class. So, the dots represent the outliners here. Moving on. Herein we have plotted certain hist plots. Again a hist plot. Hist plot is histogram. So finally, ejection fraction, serum creatinine, time, serum sodium and age are the finalized parameters, and Y is the death event. So we have classified, we have divided our required columns into 2x. X means the parameters which will help us to predict the value of y, that is the death event. So we have used standard scalar, and finally we have splitted our data set into a test size of 0.30. So 0.30, what does that mean? That 30% of the data set will be considered as the testing data set, and 70% of the data set will be considered as training data set. I hope you must be remembering the meaning of training and testing data set. If not, let's revise. Training data set is the part of the data set which is used to train the model. And finally, the test and in training data set, we also send the labels as in the y value as well. But at the time of testing data set, at the time of testing, what we do is we send our data set and we check whether the predicted value is equal to our y value or not. First of all, we'll apply Canon. Canon is an unsupervised learning algorithm, as you all know. So Canon, k nearest classifier with n neighbors 1. We have fitted the values and we have predicted. And then finally, this confusion matrix and classification report has been generated, and we can see that the accuracy is 0.74, which is not really good, along with all the precision recall, F1 score and support. Okay. Accuracy means how our value is um, related to the true value, and precision means that how the values are closed and related to each other. Then moving on to the error rate. We have calculated we have calculated the error rate, and we have represented on the graph error rate versus k values. Then last time what we tried was k equals to 1. This time we'll be trying k equals to 19. So the accuracy has not been increased much, or rather it has been decreased only. But there are certain other things such as precision, recall, F1 score and support, which might have increased or decreased. Then moving on to the logistic regression. We have again splitted our data set into two, X and Y, X train, Y train, X train, Y train, X test, Y test, with testing size 30, 0.30, again 30%. We have applied and predicted, and finally we have printed the confusion matrix, that is 0.78. So this is the F1 score, whereas the as you can see that the accuracy has been increased to 0.86, that is 86%, which is not really bad since the data set we had was actually very small and we did not apply much advanced algorithms. There are various other algorithms that we could have applied, but they are the advanced algorithms. And apart from machine learning, we could also have tried deep learning algorithms. But since we don't have much knowledge about it yet, we have tried our two algorithms, logistic regression and k-means, KNN, that is k nearest neighbors. So you guys also have to build model like this, project like this, wherein you will be comparing the results from various algorithms. And yeah, this is very basic project which was just a sample for you guys to understand how a project looks like, but you can make various innovations. And obviously, the theme of the project must be the sustainable goals, UN sustainable goals. So, all the best for you. This was all from our end. Thank you for joining.